Let us now look at equation of a pair of tangents. So this topic I will not say is very important from the exam point of view, but just this final result is what you need to remember. Maybe you might just get a question here and there. So we won't be getting into its derivation completely because it's slightly on the length. It's slightly lengthy, but I'll explain you the derivation. So after you understand the derivation, it's better you remember this final result. So in the previous case, we saw that if we have a tangent and if we have a point outside, we can find the equation of this tangent passing through this point outside, right? So assuming a tangent's equation to be y equal to mx plus c, and then putting the point inside that and seeing whether it's satisfying or not, where your c was equal to a square into 1 plus m square. So we've seen that method already before. Now we have something different. We have a point outside already. From this point, we know that there can be two tangents drawn. Can we get a combined equation of these two tangents? So this is that section. Combined equation of two tangents from outside. And from where? From this point P, whose coordinates are x1, y1. So you have a P, you have a point P whose coordinates are x1, y1. You have a circle, a standard circle, x square plus y square equal to a square, right? Centered at 0, 0, and having a radius a. What I've first done is I've assumed a point alpha beta on this tangent, right? So this alpha beta is such that it's a general point. This Q is a general point. That means it keeps varying. So this, or anything on this, any of it can be your Q, right? Right now it looks as if I've taken my Q from here, but it can be any of this. So I've written the equation of the line PQ. So this is your line PQ because you have 2 points x1, y1 and alpha beta. I've written the line's equation PQ. Now the thing is, because this line PQ is a tangent to the circle, the distance of the origin from this tangent should be a, right? Because if you drop a perpendicular on the tangent, its length should be a, which is the radius. That is the condition that I've put. So I've arranged this line first of all. First you arrange this line is in ax plus by plus c is equal to 0 form. So you can do this arrangement yourself, right? And finally, in place of xy, you'll find the distance of 0, 0 from this line. Once you arrange this line in this form, then you will use the distance formula to get the distance of 0, 0 from the line. And that distance should be equal to a. So I've just taken that condition. And now when you square on both sides, after you square on both sides and you rearrange, and finally if you replace alpha beta with xy. So why should I replace alpha beta with xy? Because alpha beta was a general point, right? Now any general point is finally written as xy, right? So this is like your locus problem, where I first take hk as a general point, and in the final step I replace hk with xy. So here instead of hk I have taken alpha beta, and final step I will replace alpha beta with xy. So when you, from this condition, if you square on both sides, rearrange and replace alpha beta with xy, you will get this condition. This is the combined equation. Now I hope you know what S means, what S11 means, what S1 means, right? So in fact, if I expand this, what I will finally get is x square plus y square minus a square, which is your S, into S11. What is S11? x1 square plus y1 square minus a square, right? This is your S11. And what is your S1 square? It's x1 plus y1 minus a square whole square. So this is the equation. What is this? What does this equation give you? It gives you the combined equation of both these. So this is a pair of straight lines actually. There are two straight lines, so it's a pair of straight lines. So pair of straight lines is homogeneous equation of second degree. So it is a second degree equation. That's why this also has basically second degree. This is also of degree 2. So this is your combined equation of both these lines. So if you are able to dissolve this combined equation, you can always split it into two separate lines, right? So that's a different thing altogether. So it's like ax plus by plus c into some a dash x plus b dash y plus c dash. So if you multiply them, you get an x square, a y square term, right? All those terms. So basically this is one straight line, this is one straight line, and their combination is basically a second degree equation, and that is called as your pair of straight lines. So likewise, this is also a second degree equation. You can always split this into this form, into two linear equations, and those two linear equations are your two straight lines, right? this was the concept of equation of a pair of tangents. All you need to remember is this particular expression, s into s11 equal to s1 square, and with this you should be able to solve most of the problems in your examinations. Let's move on to the next subtopic.